Hello viewers, in today's class we are going to discuss two important problems from indefinite integrals, right? And here these two problems are very important as far as indefinite integrals are concerned, right? So let us start and let us see how we can solve these two problems. Now here if we look at these two problems, we see that this expression, that is the integrand, consists of numerator and denominator, and in the numerator we have the quadratic function, right? So this is the quadratic function, that is x square plus 1, and here also we have a quadratic function x square plus 4, right? And in the denominator we see that we have an expression containing the power of x as 4, right? So in the denominator we have a biquadratic function. So in this class we will learn how to integrate these type of rational functions in which the numerator is a quadratic function and the denominator is a biquadratic function, right? So let us start. So let us first see the this problem, that is problem number 1, and here we can take this integral as I, right? Now in order to solve this integral, what we will do, we'll divide the numerator and the denominator by x square, right? So what we will do, we'll divide the numerator and denominator by x square, right? So what we will get, we'll have x square plus 1 over x square, then divided by x raised to 4 plus 1 over x square dx, right? Now if we separate the terms, we'll see that we'll have 1 plus 1 over x square in the numerator, and in the denominator we will have a term like x square plus 1 over x square, right? So in these type of rational functions in which the numerator is a quadratic function and the denominator is a biquadratic function, what we do, we divide the numerator and denominator by x square and we'll express our integral like this, right? And now from here we'll use some algebraic identities, right? So by method of substitution, what we will do, we'll take x minus 1 over x as t, right? So we'll put t is equal to x minus 1 over x in order to solve this integral. So if we make the square of both sides, what we will get, we'll get t square, and here we have x minus 1 whole square, right? So this is x square, here we'll use a minus b whole square, so this is x square plus 1 over x square. Then we have minus 2ab terms, so here we have 2 times x times 1 over x, so we'll have x square plus 1 over x square minus 2, right? And if we now transpose this minus 2 to the left hand side, we'll get t square plus 2 is equal to x square plus 1 over x square, right? So now from here we see that for this term we have t square plus 2, and now let us differentiate this term, right? So if we take dt over dx, then what we will get, the derivative of x is 1 and the derivative of 1 over x is minus 1 over x square, right? So this is 1 plus 1 over x square. So if we take dx to this side, so we have dt is equal to 1 plus 1 over x square dx, right? So now we see that we can replace this term, that is 1 plus 1 over x square dx by dt, right? So now our integral I takes the form, we have integral, and for this term we have dt, and see For x square plus 1 over x square, we have t square plus 2, right? So we see that when we make this type of substitution, our integral reduces to a simple one, right? So now we can write it as dt, and here we have t square plus root, this 2 can be written as square of root 2, right? And now here we will use a standard result from integration, that is integral of 1 over x square plus a square is 1 over a tan inverse x over a, right? So we'll use this result to evaluate this one. So here the variable is t in place of x, and for a we have a square root of 2, right? So now this integral can be written as 1 over root 2 for 1 over a, then tan inverse, then for x we have t, and for a we have root 2 plus c, right? Where c is the constant of integration. So now we can replace this t by x minus 1 over x. So we have 1 over root 2 tan inverse x minus 1 over x divided by root 2 plus c, right? So we have 1 over root 2 tan inverse, and if we simplify it, then we have x square minus 1 over x root 2 and plus c, right? So the integral of this rational function is given by this expression, right? So now let us solve this problem. So now in order to evaluate this integral, let us take it as I, and as we have done in our previous problem, what we will do, will divide the numerator and the denominator by x square, right? So we'll divide by x square both the numerator and denominator. So what we will get, so we'll have I is equal to x square plus 4 divided by x square and divided by x raised to 4 plus 16 over x square, right? And as we have done in our previous problem, we can separate the terms. So what we will get, we'll get 1 plus 4 over x square, right? And in the denominator we have x square plus 16 over x square, and now we'll make use of the method of substitution. So here we'll substitute t is equal to x minus 4 over x, right? Because if we differentiate both sides, see what we'll get, dt over dx, and the derivative of x is 1, and the derivative of 1 over x is minus 1 over x square. So this is 1 plus minus minus plus, and this is 4 over x square, right? So dt is 1 plus 4 over x square, and here we have dx, right? So for this term we can write dt, and if we take the square of both sides, then here we'll get t square and x minus 4 over x whole square, and if we apply a minus b whole square, we'll get x square plus 16 over x square minus 2 times x times 4 over x, and this is the t square is equal to x square plus 16 over x square minus x and x get cancelled, so here we'll have minus 8, and we'll take minus 8 to this side, so we have t square plus 8 is equal to x square plus 16 over x square, right? So now we'll substitute for this term t square plus 8, right? So now this integral I takes the form, we have here we'll have dt for this term, from this expression, and for x square plus 16 over x square we can write t square plus 8, right? So now we can express this integral as dt over t square plus 2 root 2 whole square, right? Because 8 can be written as the square of 2 times square root of 2, right? And now this becomes a very simple and standard integral, and we know that the integral of 1 over x square plus a square is equal to 1 over a tan inverse x over a, right? So here we can write for a, we can write 2 root 2. So this integral it would become 1 over 2 root 2 tan inverse t over 2 times square root of 2, and here we'll have the constant of integration as c, right? So now we can resubstitute the value of t as x minus 4 over x over here. So we have I is equal to 1 over 2 root 2 tan inverse, we'll have 1 over 2 root 2 and x minus 4 over x, right, and plus c. So we can now simplify it. So we have 1 over 2 root 2, this is tan inverse, and here we have x square minus 4 over 2x times root 2 and plus c, right? So viewers, this is the integral of this function, right?